Kia ora Year 11 and Year 12. This is an AS question that's a coordinate geometry problem. I thought I'd start doing some of the old AS papers. So this is directed for both the people in my 13 MCA class who are doing AS and also people in 12 MCA. Probably be a little bit faster for the 12 MCA people than you're used to and a little bit slower than the 13 MCAs. So in this question we've got a couple of points given to us. We've got coordinates for point A and point B. And they're in terms of k. So k is a constant. And we're told to find and simplify the gradient of AB and then show that it's independent of k. So that's obviously pretty easy, it's only 2 marks. Then we have to find and simplify the equation of the perpendicular bisector of AB. So let's quickly go over how we're going to do it. Well, we're going to have point A, we're going to have point B. We find the gradient of those two by looking at the change in y over the change in x. Now the perpendicular bisector goes through the midpoint of that line segment, and its gradient is perpendicular, not surprisingly, to the gradient of AB. We know that perpendicular gradients multiply to give us -1, so we can write m of PB is equal to -1 over MAB. That's step 1. We also have to find the midpoint, and then we're going to use the point gradient form of the equation. Well, that's what I'm going to do, which is y minus y1 is equal to m times x minus x1. So let's get going. The first thing we have to do is to find the gradient and show that it's independent of k. So MAB is equal to the change in y over the change in x. Let's have a look at what these points were. Okay, so we've got 3k plus 5 for the second y value minus k plus 3. That's the change in y, and then we've got the change in x, which is k plus 3 minus -3k minus 1. All we have to do is to clean that up and hope that somehow the k's are going to disappear. So we've got 3k plus 5 minus k minus 3 over k plus 3 plus 3k plus 1. That gives me 2k plus 2 over 4k plus 4. And I can factorise numerator and denominator. We get 2 times k plus 1 over 4 times k plus 1, which is very lovely because I end up with a gradient of 1/2. So that's the gradient between A and B, and that's independent of k. So we've done the first little bit. Now we have to find the perpendicular bisector of AB. So the gradient of the perpendicular bisector is going to equal -2, right? So we've got m times MPB is equal to -1. So I think we should probably write some statement like that down, just showing that we know that perpendicular gradients multiply to give -1. And now we're going to use a point, and we're going to use the midpoint. Right, so we've got A, we've got B, and we've found now that this gradient of the perpendicular bisector is going to be -2, and it's going to go through the midpoint. So what's my midpoint? Well, the 2 points were these, -3k minus 1, and k plus 3, and then k plus 3, 3k plus 5. So the midpoint has got the following coordinates. It's the average of these two, so it's -3k minus 1 plus k plus 3 over 2, and the same thing for the y values. Cleaning that up gives me -2k plus 2 divided by 2, and 4k plus 8 divided by 2, which equals -k plus 1, and 2k plus 4. So we know that this point is on the perpendicular bisector. And we know that the gradient of the perpendicular bisector is equal to -2. So we're ready to put that information into the point gradient formula. So this is one of the most useful bits of maths, right? It tells you how you take a gradient and a point, and from there you work out the equation of the straight line. So substituting in my point, I'm going to have y minus 2k plus 4 is equal to negative 2 times x minus negative k plus 1. Expanding everything out, we get this. Whoops. And here we get negative 2 times x plus k minus 1. So on this side now, just switching to a nicer pen, we've got negative 2x minus 2k plus 2. And you can see that I've got minus 2k here, minus 2k here. So that disappears. I'm doing this with every single little step. Finally we get y equals negative 2x plus 6. So if you wanted in y equals mx plus c form, which is how I like it, then that's going to be your answer. The Cambridge textbook and the examiner reports prefer this format, right? Y plus 2x is equal to 6. So both of those are correct, obviously, because they're describing the same line. And the other one that's quite common that I quite like is to write it in this form. And if you're doing the cover-up method that you learnt back in Year 9 or Year 10, that works quite well. Okay, so just let's check the question to see if we've answered everything. Yep, and we had to find and simplify the equation of the perpendicular bisector of AB. And we've done that, right? So we end up with final answer of y equals negative 2x plus 6. So there you go. So 5 marks for that, because there are quite a few little steps. So just make sure that you're really, really confident with finding perpendicular bisector equations, because that comes up in the AS Pure exam all the time. Thanks for watching. Let me know if you've got any questions or comments.